Hello, and welcome to the fifth video in our series about the concept of nomenclature in chemistry. Nomenclature is, of course, just a fancy word that means naming stuff. In this video, we're going to talk about how to name and write chemical formulas for acids. We will spend much more time talking about the chemistry of acids toward the end of second semester. This lesson just focuses on the nomenclature of acids. That being said, let's start with a quick overview of what an acid is. That way it's a little bit easier to apply the rules for naming them. An acid is any compound that contains one or more hydrogen atoms and that produces hydrogen ions, or an H+, when dissolved in water. The chemical formula of an acid is pretty easy to identify because it always starts with H. And there's no doubt that you're familiar with a few of these acids, whether you realize it or not. For example, HCl, or hydrochloric acid, or H2SO4, which is sulfuric acid. Notice how hydrogen appears first in the chemical formula. That's a pretty good sign that that compound is an acid. So one way that we could describe these acids is they have the generalized chemical formula of HX. And X in this case is either going to be a monoatomic ion in the case of Cl, or a polyatomic ion in the case of that SO4. And the key idea here is that we name these acids according to what X is. So based on the name of X, we can split the task of naming an acid into three rules. So first, if the name of X ends in "ide," the name of the acid is going to start with hydro and it's going to end in ic acid. So for example, in HCl, the Cl is chloride. So we name this acid hydrochloric acid. So we exchange the IDE ending for the ic ending. We add the hydro prefix and then acid at the end, hydrochloric acid. Our second rule applies if the name of X ends in "ate," as in the case of some of the polyatomics. So in this case, we're going to change that ATE ending on X to ic acid. So, for example, in the case of HNO3, NO3 is a polyatomic nitrate. And so we're going to change the ATE ending of nitrate to ic acid. So this is nitric acid. Now I also want to show another example here with H2SO4. So SO4 is sulfate. And so again, we drop the ATE ending and add ic acid. So this is sulfuric acid. And there's two things that I want to point out. One, even though this compound has two hydrogen atoms, it doesn't affect the name. And two, there's a slightly different ending change from sulfate to sulfuric. Just remember that spelling doesn't count in nomenclature. Okay, the last rule is for when X ends in "ite," or ITE. So we're going to exchange that ITE ending for us acid. So, for example, in HNO2, NO2 is a nitrite upon the polyatomic list, and so the name of this acid is nitrous acid. So the ITE ending is dropped for the OUS acid. I used a label for this name because my writing got cut off in the frame of my whiteboard, and I didn't realize it until it was too late. Okay, so again, we start by naming this acid by identifying the X in the chemical formula. So in this case, that's carbonate. It's a polyatomic, it's on your polyatomic ion list. So since carbonate ends in ATE, we're going to call this carbonic acid. So we exchange the ATE ending for ic and then add the word acid. Carbonic acid is very significant because this is the acid that's formed when CO2 is dissolved in water, and this is the acid that's a primary component in ocean acidification. So what if we're given the name of an acid and we want to write its chemical formula? Well, recognizing the name of an acid is actually pretty simple because the name of an acid always ends in acid. So after we identify that we are in fact trying to write the chemical formula of an acid, it's just a matter of applying the 3 rules that we talked about earlier. So in our first example, let's look at hydroiodic acid. Again, I know that this is an acid because the name of the compound ends in acid. And the other telltale sign here is the hydro prefix. So the hydro prefix refers specifically to an X in the chemical formula that ends in "ide." And so in this case, that's going to be iodide. Now, when we write the chemical formula of an acid, we do want to be mindful of charges. The hydrogen always has a +1 charge, and in this case, our iodide anion has a -1 charge, so this chemical formula is just HI. In our second example, let's look at the acid sulfurous acid. Again, I know this is an acid because it ends in acid, and I also notice the OUS ending. That means the anion, or X in this chemical formula, ends in ITE. So I'm gonna have to pull out my polyatomic list and find sulfite, or SO3. Sulfite has a -2 charge, so I do need to do some work before I finalize the chemical formula. You can still use the crisscross method like we did in our ionic compound videos to get the chemical formula. So in this case, my chemical formula ends up being H2SO3. Now it's your turn. Pause the video and write the formula for this acid. Okay, so we notice that the name of acetic acid ends in -ic. So that means that the anion in this case must end in ATE. So if we just work in reverse and we exchange the -ic ending for ATE, we can see that this anion must be acetate. Acetate is on the polyatomic ion list, and it's C2H3O2 with a -1 charge. Now, of course, this is an acid, so we should add a hydrogen ion to this chemical formula. And we can see that those charges balance each other out, +1 and -1. So our chemical formula for acetic acid is HC2H3O2. Acetic acid has a pretty big fan base because this is vinegar. For more information, check out section 9.4 in your textbook and watch the other videos in our nomenclature series.